Hey scholars, welcome to chapter 15.4. We're taking a look at coal this time as our non-renewable resource for this section, and we're looking at the pros and cons, advantages, disadvantages of using coal and what we've done with it so far. So coal itself comes in several forms, and it's burned mostly to produce electricity. Coal is a solid fossil fuel, so it comes in solid form, then it is burned. Burned in 2,100 power plants across the world, generates 40% of the world's electricity. Although it is somewhat relatively inefficient, there is lots of it to burn. The three largest coal burning countries are China, the United States, and Canada in that specific order. This just takes a look at the formation of coal over millions of years. How it's formed is it's peat, which is not a coal. It's literally partially decayed plants and animals. It's located in swamps and bogs, and it has very low heat content. That's what peat is. It gets put under heat and pressure, turns into lignite, which is a brown coal, very low heat content, again, low sulfur content, very limited in supplies. And again, you're decreasing in moisture content, you're increasing in heat as you move with heat and pressure. Then as you add a little more heat and pressure, it can be bituminous, softer coal. That's extensively used as a fuel because of its high heat content. And there's lots of supplies of it, which is what we mostly use there. It also has high sulfur content. And then finally, if you add even more heat and pressure, it turns into anthracite, which is hard coal. And this is the most desirable of all because of its high heat content and lower sulfur content. But most of the time, we use a lot of bituminous coal rather than anthracite because it's more to come by. This just shows you to look at a coal burning power plant itself. I'm actually going to put a link below this one of a little coal burning power plant tour so you can see what that looks like. And it goes through all these different processes and explains how this works. But basically, you have a pulverizer that actually breaks up the coal. That's used as a fuel source to then burn. The burning and the heating actually heats water, which then turns the turbine, generates the electricity, and then it goes out as waste heat, and then as it cools down, there's also a filter. Anything that's actually disposed of should filter out and then gets put into a big waste dump and then buried below the Earth's surface. So that is kind of the gist of the coal burning power plant. The video does a nice better job of explaining it, plus it gives you some better visualization, and you can see some things going on there. It is, again, the world's most abundant fossil fuel, coal is. U.S. has 25% of it. I was just watching the news the other day, and there was a couple commercials that came on CNN about, use coal, it's cleaner, we've done things better in coal and using coal, and we have a lot of it in the United States, so let's keep using coal. The environmental cost of burning coal, though, at least in the past, and they are getting better as far as filtering out coal, is severe air pollution. Because sulfur is burning bituminous coal, which is, again, higher in sulfur content, it is then released when it's burned. There's large amounts of soot, and there's large amounts of CO2, which is a greenhouse gas. There's also trace amounts of mercury and also radioactive materials held within coal at certain times, so that also is a negative. So those are some of the environmental costs of burning it. Also, the environmentalists, if you do use coal, we should be putting a taxation on CO2 produced by power plants, because again, that is influencing global warming, which we learned about last chapter. And we need to actually produce cleaner coal burning plants, which I think we are as a whole, slowly producing cleaner plants. But in back in the day, we didn't really do a good job at that. So we're doing it better now, but are we quite there as far as everything goes as cleaner coal burning? Maybe, but some people still disagree. This is kind of a picture from past, but the air pollution from coal burning is an industrial plant in India. Again, India might not have the same filtration systems that we have here in the United States, but it is still coal in general. Burning it is dirty. Let's see, it's about CO2 emissions, because it is about global warming. We've talked about that last chapter. When you do coal-fired electricity, that's 286%. Looking at that as far as energy produced for energy resources, and this is on CO2 emissions. If you're doing synthetic oil or gas produced from coal, it's 150%. Coal itself, 100%. Oil, sand, 92. Oil, 86. So it's just looking at how much CO2 is produced by using these different energy resources. Obviously, coal-fired electricity, one of the highest. And coal, and anything with coal is pretty high. Oil second, natural gas, then nuclear and geothermal last. So that's just showing you kind of in ranking order how much CO2 emissions are actually occurring. All right, so let's look at a case study. And we're going to look at China again, as we have done in past when we look through these chapters. We always compare to China, but China burns more coal than the United States, Europe, and Japan combined, and mostly because of their industry. There's coal burning plants. They're very inefficient or non-existent pollution control, so they don't have quite the efficiency or the cleanliness that they have in other parts of the world with burning coal. They are leading the area for sulfur pollution. It's a very big health hazard. It almost looks like that's why you get smogginess over there. Acid rain due to coal burning as well, so we're seeing some problems with that. There's also mercury showing up in salmon off the western coast of the United States because they're burning it, and it's actually condensing into the water source, and then we're seeing those fish show up with higher mercury. Is it from California? Probably not nearly as much as it is from all the way over in China. The air quality of Korea and Japan have been impacted as well because those are surrounding countries that are close to China. Their actually air quality has gone down because of how much coal is being burned in the inefficient or non-existent pollution control state. So coal has advantages and disadvantages. Again, single biggest air polluter in coal burning countries. 1/4 of the annual CO2 emissions. Many opposed to new coal burning power plants, but there are some advantages and disadvantages. Let's take a look at those today. One of the advantages is that we have tons of it, lots and lots of it, 900 years worth of coal, and a lot of it's located here in the U.S. It has a high net energy yield compared to other resources. It's at low cost, it's pretty cheap. There's well-developed technology. We've been able to develop even further as we've used it for a long time, and the air pollution can be reduced with improved technology, which we are getting better at. The disadvantage is that to get the coal, you have to disturb land. It has to do with mining and strip mining usually. So you're going to see air pollution, water pollution, and land disturbance when you're actually getting the coal out of the ground. If severe threat to human health when burned, if there's not proper precautions taken to reduce the sulfur emissions from that, and also the soot being produced. Environmental costs not included in market price because you're not paying for, it is relatively cheap, so you're not paying that environmental cost of that strip mining that's degrading the land. Large government subsidies are given to companies that are using coal in industry, and it's very high CO2 emissions when produced and burned. So how are you going to do that? How are you going to get rid of it? So that was our big challenge last chapter was what are we going to do with those CO2 emissions? And we looked at that carbon capture storage. Are we going to kind of implement those on all coal burning power plants? If we use those in the future, who knows? And there's also some radioactive particle and toxic mercury emissions when you burn coal because it has been trapped in the coal. So those are a couple things. We could also convert coal to a gaseous or liquid fuel source by what we call doing gasification and turning it into a synthetic natural gas from coal, or we can turn it into methanol or synthetic gasoline by coal liquefaction, which could be used as a fuel source for cars. Now the problem with this is when you convert something, we know that that second law of thermodynamics, energy is lost. So it's not going to be as efficient as just burning straight coal. But there are benefits to using those, and let's take a look at them. The advantage is there's lots of supply of coal, so we can be doing this gasification or liquefaction fairly easily. It can be used as a vehicle fuel, which is kind of our biggest issue right now with gasoline and oil. Moderate cost and lower air pollution than coal when burned. That's a good thing. The disadvantage, though, is that you're not getting as high of an energy yield, so you end up using more supplies to get less miles per gallon or whatever. Higher cost than coal. It requires 50% more coal in order to convert those. Because remember, there's going to be waste product when you're converting it to liquid or gas. Environmental costs not included. Again, high environmental impact, large government subsidies, money's going towards this, high water usage, and maybe even higher CO2 emissions than coal. So it might produce less pollution as far as like particles and soot, but it is going to have a higher CO2 emissions. So that might not be a good thing. So those are a couple of our pros, cons with coal. We'll see you guys next time when we take a little bit closer look at nuclear energy.